Go live, everyone. So my name is Jesse, and I am with Exploring by the Seat of Your Pants. For those joining us for the first time, we are all out bringing conservation, adventure, and science into classrooms around the world. And we are so excited you guys are joining us today. Over the month of April, we are going to be highlighting over 100 scientists, explorers, and amazing facilities around the globe. And today we continue our epic SciComm Storytime series. So every day, 2 p.m. Eastern, 11 a.m. Pacific time, we are going to be featuring a rock star of science communication, someone who lives and breathes the work they do and loves sharing it with a wide audience. Today, I am particularly excited because we are covering a topic close to my own heart. We are joined by Diana Alsindy. She is a propulsion development engineer, which means she has forgotten more about robots and machines than I will ever learn in my entire life. And she works at Virgin Orbit, helping make sure that spacecraft can get into space. In addition to that, she is a widely regarded science communicator. She has founded the Instagram page, The Arabian Stargazer, with over 100,000 followers from around the world. She loves to talk in both languages about all the work she does. She has been doing this for many, many years now. We are so thrilled to have you here, Diana. And so without further ado, take it away and let's dive in with all the cool stuff you get to do.
What an awesome introduction, Jesse. Thank you so much. I really appreciate it. Hi, everyone. I am not sure how many people are live, where you're from. I'm so excited to be here. If you give me 1 second, I'm just going to copy this link and share it on my page. So give me 1 second.
Perfect. While you're doing that too, I just want to stress again, we've done these for the last couple of weeks. So if you want to check out more really, really cool people with SciComm Storytime, they're all on our YouTube channel. You can check in there and subscribe, and we encourage you to do so. Plus our Twitter page, where we highlight new people coming in every single day, including, as I keep mentioning, the SciComm Storytime series. Thank you for sharing this, Diana. We really appreciate it.
I just shared it. We are ready to rock and roll.
Perfect. Let's do it.
All right. Everyone, my name is Diana Alsindy. As Jesse mentioned, I'm a propulsion development engineer as well as a bilingual science communicator. I'm so excited to be here to share with you my story and a little fun science story that I encountered through my career. I'm going to share my screen so you can see my presentation. Let's see. Ooh.
Perfect. Good to go.
I'm trying to get perfect. You can see my full screen?
Yep.
Awesome. So these are all the social media accounts that you can find me in. I'm sorry that my Twitter handle looks so weird, Arabian Star 1. The Arabian Stargazer on Twitter was taken. Today we'll be talking about rocket science, fire, and more. I have been a little backstory about myself first. A big part of where I came from is part of my story. I'm originally from Baghdad, Iraq. I immigrated to the United States, specifically California, at the end of 2008. So I was 14 years old. And I get a lot of the same question all the time is, how did you get here? How did you become somebody who's working on rocket science and you didn't know any English when you came here? So in 2010, I went to high school and I didn't know any English. I didn't have any friends, and being in America was very different for me. But because I was 14, I got adapted really quickly and I was able to go into college, and I got a chemical engineering degree from the University of California, San Diego. In college, I acquired a lot of internships with Virgin Orbit, NASA, Northrop. I got really interested in rocketry and propulsion engineering specifically because of the clubs and rocketry classes that I took in my university. So then, after my last internship, I got a full-time job with Virgin Orbit working on propulsion engineering, stage systems specifically, and Virgin Orbit, if you did not know, it's a satellite company that takes small satellites to low Earth orbit to do whatever mission that the satellite is meant to make. So in 2018, In 2018, I was sitting in my living room thinking, there must be something else that I can do. It isn't possible that I go to work and 5 and I go home and don't do anything So I wanted to utilize my language to create a platform called Arabian Stargazer on Instagram to test out the water, to see people really interested in space in the Middle East want to create space camp all around the Arabic world. Would people be interested, or it will be just a lost cause? So I stand for space for everyone. And when I mean by everyone, I mean everyone, not only English speaking enthusiasts. So since I'm fluent in Arabic, I chose to share with Arabic as well, and hope to inspire other people to share science in their own native language. So if you want to see what that is all about, go to the Instagram, the Arabian Stargazer, and you can DM me, message me, email me. I hope I'm easily found on social media. So today, my topic is space. A lot of people are interested in space, especially young kids, looking at the stars, looking at the sky. You have a little telescope to discover what that is all about. So I have a really cool story to share with you today, but first, let me talk to you about a little bit about my job and the science and mechanics behind my favorite day as a rocket scientist. So as I mentioned, I'm a propulsion engineer, AKA the rocket scientist, but I don't like to call myself that. Rocket scientists don't really exist. We did not reinvent the wheel of the rocket equation. I work on building and designing rockets that go to space. So let's talk a little bit about the science and mechanics behind rocket science and engines specifically. So let's start with a guessing game. I am not sure how many of you are watching and where you're watching from, but can you guess how old Earth is? Tell your neighbor. It is 4.5 billion years old. It is quite old, but this Earth is in the solar system. How many of you know how many planets are there? All right, you can count it right here. There are 8 planets in the solar system. Humans have built satellites that reached Mercury, Venus, Mars, Jupiter, Saturn, and humans have also been to the moon. So through space technology, we were able to learn more about our Earth. So your phones, your GPS are all thanks to space, thanks to satellites. So the entire solar system is inside a very large universe. Inside this universe, there are several thousands of galaxies, each consistent of billions of stars. So each light speck that you see here, I'm gonna have my laser because I feel cool using it. Each light speck is a galaxy. So imagine inside this galaxy, there are so many stars and so many other things that you can't really see with your naked eye. Some of which are old as, guess it? Did you guess it? 13 billion years. So all of these awesome planets in our system, how do we even know they exist? And how do we know how to reach them? So this is thanks to space technology, satellites, and rockets. So let me tell you a little bit about this awesome scientist named Isaac Newton. He thought of an experiment used to hypothesize that the force of gravity was universal, which is something called the law of universal gravitation. Imagine you're on Earth and there's a mountain so high that its peak is above the atmosphere of Earth. So you're just like all the way in the space. Imagine on top of the mountain, there is a cannon, and that cannon is shooting cannonballs. It fires horizontally. So when you have, I don't have anything to throw here, I have medicine. So if you're throwing this medicine all the way, oh, that was my mom's medicine. So imagine on top of the mountain, there's this cannon and it fires horizontally. The further you throw it, it's because of the force that you're throwing this cannon. So as more and more charge is used with each shot, the speed of cannonball will be greater and greater, and the projectile with the impact on the ground goes further and further from the mountain. So imagine this cannonball, if you throw it at a certain speed, it will not hit the ground anymore. It will fall toward the circular Earth just as fast as the Earth curves away from it. So this concept is called drag. In the absence of drag from the atmosphere, it will continue forever orbiting around Earth. So I hope I explained this well in the 1 minute I had. It was the first and best explanation of what an orbit is. It's an object in orbit when it's weightless, not because there's no gravity, Earth's gravity in space, but because it is in free fall, just like a skydiver. When you're skydiving from a plane, you don't just fall on the ground and die. That's weightlessness, basically. It's free fall. So the difference is that it has enough horizontal speed to never hit the ground. That's why satellites always go around orbit until, they crash into something and stop working. So how do we use that concept on rockets? Well, this is how rockets go to space and don't fall back on the ground. Imagine if you have, I should have had a balloon, but imagine if you have a balloon, right? And if you fill the balloon with air and hold the neck closed, just like we have right here, you have the neck closed, this is the neck. The pressure inside the balloon will be slightly higher than the surrounding atmosphere. And by surrounding atmosphere, I mean the air around the balloon. However, there's no net force on the balloon in any direction because the internal pressure inside of the balloon is equal in all directions, which I mean, if you blow right here, the pressure in all directions around the walls of this balloon will be the same. So when you release the opening of the balloon, gas will quickly escape to equalize the pressure inside the air pressure outside of the balloon. That escaping air exerts a force on the balloon itself, and the balloon pushes back in a manner described by Newton's third law of motion. That opposing force is called thrust. So when you hear someone saying, all right, this rocket has 80,000 pounds of thrust, that's a very powerful rocket because it's going to go to space and it has enough thrust to get the satellites to space. This concept, the balloon concept, is actually used in jet engines and rocket engines. This is how rockets go to space. Inside this big star, red star, is basically the combustion chamber where we have the ignition, the chemical reaction. This chemical reaction usually happens between a fuel and an oxidizer. In this case, I used, for example, RP1 and liquid oxygen. When that combustion happens, fire happens. And that fire is going to push the rockets forward to space. So usually in rocketry, we have 2 stages, 3 stages, whatever, however big your rocket is. The bigger it is, the further it's going to go to space, obviously. So first we have the first stage engine, or the upper stage. Then we have the second stage engine. Then we have the payload. So in a typical case, the first stage and booster engines first is used to propel the entire rocket forwards. When the first booster runs out of fuel or thrust or force, whatever you want to call it, then it's going to detach from, this is why you see the detachment, it's going to detach from the other stage and it's going to fall back on Earth. This leaves a smaller rocket, and by a smaller rocket, I mean this. This is a smaller rocket with a second stage on the bottom, and when it fires, it continues happening until you get to wherever you want to go to space. This little payload, it can be as small as a cereal box. It can be as small as a mini refrigerator, or as big as the International Space Station, which is like a very comfy 5-bedroom house. There are around 3,000 satellites made by humans that are orbiting Earth right now. Each of these have been placed in orbit by a rocket. That's why rockets and satellites go hand in hand. And I wanted to talk to you about this because this right here, this what you see is what I tested at Virgin Orbit about a year ago. So the reason why I told you the story is because I wanted to explain to you this test. It is called Mission Duration Cycle, MDC, which means whatever is happening to that rocket stage in space, we wanted to test it on the ground. So let me show you what it is. I'm going to show you a video. And once you see the video, I'll explain a little bit further. All right, how do I play? Oh, now I know why Sam was confused. This is confusing. How do I, here you go.
Perfect.
Can you hear the? It's gonna do that for a whole minute.
And where is this launch pad, Diana?
It's in Mojave, in California. It's in the middle of nowhere, Mojave Desert. So I don't think I can.
That's okay, no worries.
So you get the idea. So this video was 1 minute, but in reality, that fire ran for 3 minutes. So when we take, if I go backward, when this goes to space, this little engine that you see right here, laser pointer, this engine is going to run for 3 full minutes, and it's going to generate 75,000 pounds of thrust. That first stage is going to detach, and it goes back, to the ocean or Earth or whatever, and then the second mini rocket is going to go to space to take this satellite. So that day, it was very stressful. I felt the passion and excitement and hard work of engineers and scientists. I was about 3 miles away. So if we play this again, and then I'll pause it. I was right here, 3 miles away. Pointer again, 3 miles away from this test stand. This white thing that you see, this is what's called a test stand. It is what holds the rocket to the ground to make sure that it's not launching when you're testing it. So during a mission duration cycle, what you want to do is you want to replicate exactly what's happening to space on the ground. You want to make sure there are no leaks in your valves and your tubing and your entire rocket. You want to make sure there are no software issues. And what I was specifically doing, I was monitoring something called the PPMS, which is Propulsion Pressurant Management System. And by that, I mean everything on the rocket but the stage. I was monitoring the sensors, making sure that our pressures are ideal. They're not too low, they're not too high. If they're too high, the rocket might explode. I was measuring and calculating and monitoring sensors for temperature, making sure that we're not too cold and not too hot. And the reason why this specific test was difficult and why rocketry is difficult is because it's not like a car engine or a car. When you're driving and your oil is too low, you get an engine light and saying, hey, you need to check something in your car. With rocketry, you don't get that. Everything has to go right in the same moment, and you don't get lights, and you get warnings, but these warnings are pre-calculated. So if there's something that you didn't pre-calculate in advance, things might go wrong. So this was a really exciting day for me. I tried to explain the mechanics and science behind it. If you have any questions, feel free to ask me. I'll share as much as I can. There's a lot of ITAR information. But yeah, if you have any questions, please share them with me. I don't know how long that was. 15 minutes exactly.
You're great. It's perfect. Perfect length. Diana, thank you so much for such a neat presentation on you and some of the cool stuff you get to do. You can leave that slide up for a minute and then come out of screen share and we'll see you again. For everyone tuning in on YouTube, let me know where you're joining from. Type in questions in the chat bar and we'll pass along as many as we can in our time left. Diana, I want to start, when you showed the rocket development, there was fuel and oxygen. So most of us think of just oxygen being in the air. Why would oxygen need to be inside the rocket with the fuel?
The same way that you have a regular fire, if you're camping, you need to make that chemical reaction. So that chemical reaction is going to ignite. So a lot of times we have different techniques of ignition inside of an engine. Sometimes it's a spark plug. Sometimes it is different chemical reactions that you can purchase from certain companies. Having that oxygen will generate the fire, because fuel by itself, like you go to a gas station and you're pumping in fuel. If you have oxygen in the same time, then you're going to make fire. So that's why we don't want to have fire when you're in a gas station, but we want it when you have jet engines.
Very cool.
By the way, Jesse, I don't see the chat.
So, oh, you don't see the chat? That's okay. I got it on YouTube beside me. So you can just focus
Perfect.
on me and I'll share any questions that we might be getting. We've got people joining in from San Francisco and Baghdad, by the way. So that's really exciting so far. All right. So you talked about being involved with Virgin Orbit. There are other companies right now that are starting to put up satellites themselves as well. I've heard it said that there's sort of a danger of too many satellites being up there. Can you speak to the number that are going up and what that might represent in the coming years?
So there are about 3,000 right now, probably going higher as we're speaking, because even universities and high schools, and I think some people in middle school are building CubeSats and satellites. The reason why I don't think it is dangerous, because I addressed this in my page one time, you wouldn't even comprehend how big space is. So when you say there's 3,000 going in space, space is so, like, each satellite is so far away from each other in space. So the chances of it hitting each other or causing some danger, it's very, very low. However, I do agree that we have space debris, which is basically, they call it space trash. And there are a lot of companies coming up right now creating ways to mitigate that and try to recycle these CubeSats. I know a lot of my followers are always excited to learn about how to pollute space less, but I don't think it causes any danger because the distance between each satellite is so far away because space is so big.
Fantastic. All right. This is a question we get for every one of our sessions in SciComm Storytime. So do you have a favorite part of your job? When you go to work in the morning, is there something that you really look forward to most of all?
So this is a very ironic question to ask because I've been home for 3 weeks and I'm away from my coworkers and from hardware. I really like the environment of working with people. This is why engineering is so fascinating and so fun, because there's no way you will solve a problem fully on your own. There's so many people are involved, so many different brains and so many different talents and passions. And what excites me the most is if I'm stuck in a problem, there's a way where I can go and ask somebody, some expert, for example, or another engineer or another scientist. So the working environment and how there's so many people work on the same thing, it's exciting. And specifically at Virgin Orbit, what I appreciate is the fact that I can go and be inside of a LOX tank if I want to. I can go work on engines or hardware. LOX tank is the liquid oxygen tank, by the way. So what excites me is I can do that if I want to. I have the freedom and ability to work with people and on an office desk, or I can go and work on the floor with hardware.
Yeah, every day is a little bit different, which is fantastic. We get that from a lot of our speakers, so thank you for that. All right, Emily Calandrelli, who of course did our first session for SciComm 3 times, she has a question for you.
Hey, Emily.
What type of content do you find your English-speaking audience likes the most versus your Arabic-speaking audience? Is there a difference, or do you find anything?
There is a difference. There's a lot of differences. With English speakers, because the space accessibility, it is out there. You go YouTube, combustion chamber on YouTube, there is millions and millions of videos talking about that. Versus if you write that in Arabic in YouTube, there isn't much content. So when English speaking are asking me questions, they're technical questions. They are things that could be, explained because if I am subject matter expert, versus if you're an Arabic speaker, your questions are not as complicated because you just simply don't have the knowledge or resources to know these things ahead of time. With Arabic speakers, they want to learn about these things, but the concepts are a little bit simplified, if that makes sense.
Yeah. Well, so, I mean, again, this is such an amazing service that you're providing, and the fact that you're speaking in both languages and that you have such a following. I mean, again, we've literally never had people from Iraq tuning into our broadcast, and we have many just because of you, so we really appreciate that. So are there things happening in the Middle East? Is the sort of work that you're doing inspiring people to, are there space programs in the Middle East? Are people doing some great stuff? Can you explain a little bit about that for some of our English-speaking audience that might not hear those stories typically?
Yeah. This is funny that you mentioned this. Just yesterday, I met somebody who is holding rocketry and space STEAM camps in refugee camps in in Jordan. This makes me so excited and so happy because when you say space for everyone, you have to really include everyone, not just English-speaking populations. UAE is doing awesome work. I was there a few months ago. The amount of passion and excitement that's coming from young Arabic youth is fascinating, specifically into space. We have people creating content in Arabic because when I started the Arabian Stargazer in 2018, there was no content in Arabic about space. And when you do this, people will try to do the same thing. And I think the future is going to be bright for the Middle East because there's a lot of people who are interested in space and seeing why space is important.
Very, very cool. Thank you so much for that. All right, your career has this like rocket-like trajectory. You've done so much so fast. Is there stuff that you really like to be involved with in the future of space exploration? I mean, this is such an exciting time in space exploration. If you could explain a little bit about why that is generally, but is there anything that you'd like to do particularly?
And specifically in rocketry, I really like propulsion, but I also like business development. I like to see the opposite side of the company. How are we talking to our customers? What kind of deals and technologies that our customer wants to see? When I'm behind the screen working on very, very specific problems to solve in my day-to-day job in propulsion, I don't get to see the bigger picture. I've always been interested to see the bigger picture and see what is happening around the space industry from other companies. So maybe in the future, I get to join the business development team and understand the technical side behind it because I was a technical engineer earlier.
We look forward to doing another session when you're a CEO in like 5-10 years. Okay, so we'll be back then and check in.
It's going to be a while from now.
So I've had the chance to see a rocket launch live. It was one of the coolest things I've ever done. I'm sure you've seen rockets take off, not just burn, but actually go off into space. Where can people go and see a rocket launch in the world? Like if you can, is there anywhere that jumps to mind? The Mojave Desert, are people able to go there or not?
So with Virgin Orbit rockets specifically, it's not going to look like a typical rocket launching. It's not going to be vertical, for example. We launch it from a Boeing 747 plane. So we carry the actual rocket to a certain altitude in space, and then we throw the rocket, and the rocket ignites and it goes to space. So we would not have a landing or a launching pad, just like SpaceX. But if you do want to see rocket launches, you don't have to see it to be in person. I actually don't think I've ever seen a rocket launch in person. Yes. And that is because we don't have many places to launch rockets. And that's why we need more space agencies and companies to launch rockets. So you can go to Florida, for example. You can go to Mojave Desert. There are small universities who are launching rockets all the time. I've seen my university rocket once. But if you are interested, I have a post on my page that talks about all the different websites that you can go to see rocket launches. So hopefully after this quarantine and coronavirus stuff, more companies will be launching rockets.
We would love that list or link to your page because we'll share that on our social media so that people can check those out. Yeah. For anyone who's just tuning in at home, check out YouTube to watch one of these planes launch a rocket because it is so cool. It's like the neatest thing ever. Yeah. All right, Rabia Khan wanted to know, are all rockets built the same? Who would be the leading edge in design for rockets, or what is the leading edge in design for rockets?
Not every rocket is the same. As I mentioned earlier in my slides, you can have 2 stages, 3 stages. It depends on how far you want to go to space, and it depends on the velocity and mass that you want to reach per rocket. The leading edge, it's sustainability. I think the more rockets that you make per year and you get to use again, the cheaper it is. And if it's cheaper, it means you can make more. So SpaceX, for example, has been recycling rockets ever, I don't know what year they started. It feels like a long time ago. And that made the rocket price much cheaper so they can reuse these parts, because I see how rockets are built. It is freaking expensive. And these parts are designed in a way where it is so unique, and you can get it wrong really easily. And if we can design things once and design it well, we get to test it and see that it's working. Then if we could use that part again, that would be great. So reducing the cost of rockets is going to help us in the long run, because more companies are going to be building rockets and it can cost cheaper, and we get to send more satellites to space. We can make more space exploration discoveries.
Yeah. So I want to harp on this space exploration discovery piece. So you mentioned rockets being expensive, and we're talking hundreds of millions, if not billions of dollars. So for someone sitting at home wondering, how can we possibly justify that sort of cost to send something into space? Why are we doing this? What is the importance and the knowledge that we're gathering?
I mean, just compare it to other things that we're spending money on. We're spending a lot of money on military and weapons and all of these things. If you compare what we're doing with space, it's literally like 1% of that. So we do have the money for it. And the reason why it's important, because you're using it every day. The reason why I'm able to talk to you and you'd be able to take questions from other continents is thanks to space. Thanks to the technology that we developed through space exploration. And we won't be able to save our planet from a bunch of these disasters if we don't know how to predict it very well. So understanding Venus or Mars, for example, it can help us with things that we didn't even think about on Earth. So that's why space is so needed, and we're not spending that much money. To the average person, yes, but
yeah, I've always loved the analogy that if all the budget of the United States were on a dollar bill, it wouldn't even cut into the ink the amount that is being spent on NASA and rocketry. So it's 4/10 of 1 penny. Last time I heard.
I've never even heard that, and that's awesome.
There you go. For all the knowledge, all that understanding, all the people, all the astronauts. I mean, it's such an amazing. It's so much gathered for so little, relatively speaking, that it's an unbelievable investment.
Yes.
Diana, we have whipped through this, and now we're out of time. So before we wrap up, you talked about some great resources. Where can people go to find out more about you, more about the work that you're doing, Virgin Orbit, all this great stuff? And I know you've highlighted it, but let's reiterate it for us.
Yes. So if you go to Instagram, thearabianstargazer.com. I don't know if I write it here, the Arabian Stargazer, would it go through? Yeah. The Arabian Stargazer, that's on Instagram. If you do thearabianstargazer.com, that's my website. I'm trying to make it also bilingual, so you can click one button and it translates it to Arabic. If you have any questions about rocketry, about starting your own club in your country or university, I would love to help and collaborate. It is so much easier than you think. And I think the future is space, and the future are the people who are watching. There's so much hope out there, and I believe that we can do great things.
I couldn't wrap it up better if I possibly tried. Diana, thank you so much for joining us today. We really appreciate you sharing your story. And again, this is part of the SciComm Storytime series. So everyone, 2 p.m. Eastern, 11 a.m. Pacific, amazing people like Diana. Diana, what a pleasure. Thank you so much.
Thank you so much, Jesse. Bye, everyone.
Bye, everyone. See you soon.